Ignition sequence starts.
Good morning, and welcome to this view of the International Space Station Flight Control Room and the team of specialists on console this morning, working with the Expedition 65 astronauts and cosmonauts near the end of a very busy week in space. Commander Aki Hoshide and his American, Russian, and French crewmates spent the week doing science research in low Earth orbit, while conducting another spacewalk on the Russian segment of the station and preparing for a U.S. spacewalk targeted to take place this weekend.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Nilofer Ramji. Another week of spacewalks and biomining with microbes are just some of the exciting things happening aboard the International Space Station. On Thursday, September 9th, Russian cosmonauts Oleg Novitsky and Pyotr Dubrov ventured outside the Poisk airlock and continued to prepare the new Russian multi-purpose laboratory module for operations. This is their second spacewalk in a week and is a part of a series of spacewalks required to complete the outfitting steps for the new module. 3 days later, on Sunday, September 12th, JAXA astronaut and station commander Aki Hoshide and ESA astronaut Thomas Pesquet will exit the Quest airlock to modify the port for truss structure and prepare the orbital lab for its third set of rollout solar arrays. You can watch the spacewalk on NASA TV, nasa.gov, and the NASA app. Coverage is set to begin at 7 a.m. Eastern Time. In science this week, new developments on biomining with microbes and investigating genes expression in space, with the 2020 Genes in Space Challenge winner kept astronauts busy aboard the orbiting laboratory. New results were recently published on the BioRock investigation, which demonstrated how microbes can extract rare earth elements from basalt in space. Basalt is a common rock on the Moon and Mars. The team has now shown that microbes can not only mine elements in space, but some microbes may also perform even better under such altered gravitational conditions. BioRock researchers observed an increase of vanadium biomining as much as 283% under reduced gravity conditions. These results show that biomining may be possible on a larger scale in space, extracting elements that humans need to sustain themselves independent of Earth. Some pharmaceuticals used to maintain astronaut health do not work as well in space. This may be linked to changes in levels of the liver enzymes that metabolize most drugs. Genes in Space 8 tests the Genes in Space Fluorescence Viewer, a new technology for visualizing biomolecules like DNA. In this investigation, it will be used to monitor the expression of genes that control critical liver enzymes. This test could lead to a better understanding of spaceflight-induced changes in liver gene expression and may support the development of new therapies that can account for the body's adaptations to spaceflight. The tool being tested to study these changes in space could also aid in patient monitoring in remote areas on Earth. That's Space to Ground for this week. For all of the latest updates, head over to nasa.gov. Thanks for watching. We'll see you next week.
The astronauts and cosmonauts on the International Space Station spend a lot of their time working on science in a wide range of disciplines. The station also serves as a platform for instruments that study the Earth below, including looking at colorful bursts of energy that take place above thunderstorms. These instruments help scientists study these transient luminous events that may prove useful to better understand our climate, our weather, and the behavior of storms.
If you're on the ground during a thunderstorm, you might witness a spectacular show of lightning. But if you're observing that same thunderstorm from the vantage point of the International Space Station, you might see a bolt of energy shooting up from the clouds, and it might be red, or blue, or even green. These particle outbursts are like nothing seen from the ground and may prove useful to predict weather outcomes more precisely, better understand changes to our climate, and increase the safety of planes and ships approaching dangerous storms. They have names that sound like they were taken from a fantasy novel: Blue Jet, Gigantic Jet, Red Sprite, Halos, and Elves. But all belong to a more scientific-sounding family, transient luminous events, or TLEs. Flashes and glows that appear above storms that are results of activity occurring in and below those storms. Dr. Timothy Lang is a lead research aerospace technologist at NASA's Marshall Space Flight Center. He explains how two key observational instruments aboard the orbiting laboratory are helping scientists better understand these colorful bursts of energy. We use the Lightning Imaging Sensor, or LISS, to map lightning in 2 dimensions with global scale coverage. It shows us where the thunderstorms are taking place and how powerful each one is based on the size of its lightning flashes. So it's akin to a macro camera. Another instrument, the Atmosphere Space Interactions Monitor, or ASIM, is operated by the European Space Agency. ASIM gives us very fine detail of a TLE's flash. In essence, it's akin to a microcamera. Torsten Newbert, ASIM principal investigator at Denmark's National Space Institute, adds that ASIM and LISS make observations in different ranges of the color spectrum, allowing for different views of these particle events. So LISS is macro, ASIM is micro, and together they provide a powerful combination for exploring lightning and TLEs. The space station offers an excellent vantage point to scientists studying TLEs. At about 250 miles up, it is much closer to these phenomena than a geosynchronous satellite. Further, the station's orbit allows for coverage of storms worldwide. All this allows LISS and ASIM to produce a unique space-based data set of thunderstorms and their effects, which in turn helps support other observational instruments. LISS, for example, has been used to calibrate instruments and verify data for the geostationary lightning mapper on NASA and NOAA's GOES satellites, and will also support the lightning imager on the European satellite Meteosat 3rd generation. This support helps make data produced by these sensors the highest quality for serving the public. From the space station, LISS can provide lightning data in near real time for the benefit of those on Earth. It can report lightning nearing dry areas of forests prone to wildfires. It's integrated into the NOAA Aviation Weather Center's operations, which provide weather forecasts and warnings to the U.S. and international aviation and maritime communities. And over time, it can map data points to help scientists observe changes to our climate over broad tracts of land and sea. In short, studying lightning and its effects both below and above the clouds can have a big impact on how we view our planet. Doing so from the International Space Station is improving that view in ways that couldn't be accomplished anywhere else. For more electrifying information about the International Space Station, go to www.nasa.gov/ISS-science. To discover more about the space on, around, and beyond our planet, visit science.nasa.gov.
When you look up at the night sky, you notice that the moon appears to change shape from night to night. Those different shapes that we see at different times of the month are called the moon's phases. In this demonstration video, NASA astronaut Anne McClain and a friend with an Earth-shaped head explain why the phases of the moon occur as they do.
Hi there. My name is Anne McClain, and I'm an astronaut who has lived and worked 250 miles above the Earth's surface on the International Space Station. Today we're going to be turning our eyes toward the moon and learning more about what causes the moon phases. But before we check out the moon phases, let's take a look at where the space station is compared to where we are on Earth and where the moon and the sun are. On Earth, you're only about 250 miles below the station. The moon, however, is located 238,855 miles on average from Earth. You could fit 30 Earths in that distance. When you think about how far away we are from you on the station versus how far away the moon is, the station is only a tiny bit closer to the moon than we are here on Earth. And that's only when the station is in orbit on the same side of Earth as the moon. So, the station is 250 miles away, the moon is 238,855 miles away, and the sun is approximately 92,900,000 miles away. That is quite the distance. Now that you know where you are relative to the station, moon, and the sun, let's talk about the moon phases. Now, when you're looking up at the moon from the Earth, you'll notice that it looks different from day to day. We call these differences the phases of the moon, and they cycle through every 30 days. Let's check out a demonstration of the moon phases here on the ground. We're going to pretend his head is Earth, letting him view the moon as you would from your home. The ball in their hand is going to represent the moon, and the light source is going to be our sun. Keep in mind that while the moon is orbiting Earth, Earth is also rotating on its axis and slowly orbiting the sun. Now, looking from our outsider perspective, we can see the moon is still whole the entire time it is orbiting around Earth, with the side facing the sun always illuminated and reflecting sunlight. Let's take a look at what he is seeing. As you can see in the photographs from Earth's view, the reflection of sunlight looks quite different from this angle, since we are only able to see parts of the reflected sunlight as the moon moves around Earth. This is what causes our moon phases, as the moon orbits around Earth every 30 days. There are names for each of the phases of the moon's 30-day cycle. When the moon looks completely dark, we're experiencing a new moon. This is the beginning of the 30-day cycle. It will move through a waxing crescent phase until it is a first quarter moon. From here, we will see a waxing gibbous until the moon appears fully illuminated. You might have heard this phase before. This is what we call a full moon. After this phase, the moon will go from a waning gibbous phase into a third quarter moon. After the third quarter moon, it will become a waning crescent until it returns to a new moon. On the space station, we see the same moon phases as we do on the Earth's surface. Since the space station is only 250 miles closer to the moon than we are here on the ground, astronauts on the station have the same perspective you have, but don't have the Earth's atmosphere in their way for photographs. Astronauts currently on the space station actually use the moon's phases to collect research that will help NASA with the Artemis program as we work to go forward to the moon with our astronauts by 2024. So, the next time you're outside, take a glance up at the moon to check out what phase it's in. Are you interested in seeing the space station fly by as well? Ask an adult to help you sign up for Spot the Station at spotthestation.nasa.gov. Thanks for learning with me today. See you next time.
We have mentioned a time or two that the International Space Station is not the only NASA mission that is creating benefits for those of us here on Earth. The Earth, by the way, is just one of the planets that NASA studies from orbit. In the case of this blue marble, tracking agricultural conditions helps the inhabitants keep track of food security issues. Our colleagues at NASA's Goddard Space Flight Center have a look at how NASA can monitor agricultural conditions around the world to support the creation of, among other things, the snacks we all enjoy.
We use satellite data to track...
Hello, my name is Jocelyn Argueta, and this is Snack Time with NASA. Today we're making a big favorite in my house, chips and dip. We are NASA though, so this isn't going to be your run-of-the-mill dip. This will be a 7-layer cropland dip. Stick with me here. Did you know that NASA plays a big part in the food you eat? We use data from space to monitor agriculture and track food security. So coincidentally, we have some of the crops that we keep an eye on. Get it now? 7-layer cropland dip. So we can send a rover to Mars, but now the question is, can we make a tasty dip? But before we get started, I want to welcome Dr. Yvonne Becker-Reshef, who's here to tell us all about NASA's connection to the food we eat. Hi Yvonne, how are you doing today?
Hi Jocelyn, great. How are you?
Awesome, it's great to have you. So first things first, are you a fan of chips and dip?
I love chips and dip. Yes.
Oh, good to hear. So as the director of NASA's Agriculture and Food Security Program, can you tell us a little bit about why NASA studies agriculture in the first place when we're known more for space exploration than cooking?
As we all know, our planet Earth is also a planet, and so NASA has satellites that are pointing out into space, but it also has a lot of Earth observing satellites pointing here down at Earth. And of course that's really critical because we live here, and that's important for us to track and understand how we're changing our planet, how our planet is responding, and in particular tracking agriculture, which is what we're concerned with here. Food security and agriculture are one of the biggest challenges we face in this century. And NASA's satellite data, since actually going back to early days of satellite monitoring, there has always been a large focus on agriculture. Agriculture covers a huge part of our land system, and what that does is that helps us to get an accurate and a timely understanding of potential shortfalls or surplus of crops and food production around the world.
So it sounds like everything is connected, much like different ingredients in a larger dish. And I've just laid down the first layer here of our dip, which are refried black beans. And sounds like Earth observations work in a similar way where things connect together. So how do these observations help us better understand food security and food production, especially in the face of climate change?
As we said, food security is one of the most important and critical challenges that we face. And so therefore having information about where food is being grown, how much of it is being grown, how it's changing over time, how it responds to different climatic factors, to extreme weather events, which of course, as you've said, under climate change and a warming climate, we're seeing more and more erratic weather impacting our food production. And so we have various satellites going up above and turning around us all the time that are helping to monitor different aspects of the agriculture, of our agricultural system. And whether it is for helping us to distinguish where, for example, corn is being grown around the world, how it's developing, how it compares this year versus last year, for example, in the Corn Belt in the United States. And so being able to provide us that information in a timely manner on a global scale is really critical for understanding and making decisions relevant both for food security and for sustainability.
And we do have corn here as one of our layers. We also have rice, we have avocado and the guacamole. Can we see any of these staple foods being grown in the US?
Absolutely, and that's a large focus both of USDA, for example, and that NASA has partnered with very closely for many years now. And what they're focused on is utilizing satellite data for being able to monitor the extent of crops of where corn is being grown versus soybeans versus wheat. And as we know, if a farmer plants corn this year, he might plant soybeans the next year. So it's very important in the US, and USDA has a large focus on that. But also, given that our food system is so interconnected, being able to monitor both inside the US and globally, and satellites enable us to do that.
So you monitor crops all over the world, but who ends up using this data and how exactly does it help? Is it whole governments that rely on it, or do small-scale farmers and land managers use it?
That's a great question, and in fact it's everybody. It's ministries of agriculture, it's statistical departments who are trying to estimate how much production they're going to have of different crops. It's the early warning community, the humanitarian community, who are trying to assess where there are going to be food shortages and where there will need to be either food aid or other mitigation activities. And it's of course also farmers. And one example is the Crop Monitor program under GeoGlam. This provides information at the global scale on a monthly basis operationally, really targeted more at policy makers who need to have a very quick way of understanding what are global crop conditions. And so we've been working with that policy community for a long time to develop products that provide us a good global picture of crop conditions and food supplies across the world.
So our dip's moving along here. We have corn next. And it sounds like a lot of the information you've talked about could help forecast events like food shortages. Is that right?
Yeah, that's absolutely right. And so what we try to do is use the satellite data to give us an early warning as soon as possible, and really we start to monitor crops as soon as they're in the ground and growing, and try to put an alert as early as possible if we start to see, for example, the impacts of a drought developing, and track that through the season. And this information, as early as possible, is really critical for policymakers, for governments, to be able to take mitigation actions to prevent food shortages or to prevent the biggest impacts of food shortages and implement mitigation strategies well ahead of time.
And I know that NASA works with the USDA, and so why is it important that agencies like NASA and USDA work together?
USDA is the United States Department of Agriculture. They are responsible for providing global information on a monthly basis on crop production, and their forecasts set the gold standard to which agricultural commodity markets react to. So as soon as those numbers come out every month, you can see the reaction and the response in international markets. And so it makes a lot of sense for us, for NASA to be working very closely with USDA to ensure that they're able to take up the best technology and analytics to inform their forecasting and their policy development and decisions ultimately.
It sounds like it's such an important and exciting time now for agriculture monitoring.
Yeah, it really is an exciting time for agricultural monitoring and for its potential to help inform both our food security and sustainability decisions, and to help get us towards the SDG goal of zero hunger, increasing food supplies, and at the same time doing that in a sustainable manner.
Yeah, absolutely. That's amazing. And what's also amazing is our dip here, which is almost complete, but I think we can all agree that what would make it perfect is a healthy layer of cheese. Delicious. There we go. Thanks so much for joining us today, Imbal, and for sharing all of this really great information. And thanks everyone for watching. Happy snacking.
The astronauts who fly to the International Space Station get an opportunity that most human beings don't get: to see the planet Earth from above. It's an experience that has been transformative for many of those lucky enough to have been there. Canadian astronaut David Saint-Jacques had his first wide-angle view of Earth in December 2018, but he remembers it like it was yesterday.
Launching to space, of course, was a momentous experience, but oddly enough, it was quite familiar because of all the training we had. So those 10 minutes in the capsule riding the Soyuz rocket, there was the vibration, the pressure, the acceleration, the pressure in your seat. But after those 8 minutes of busy time and hyper awareness, if you want, of our environment, is when I had my first view of the Earth from space. The launch was at dusk, so quickly we entered penumbra and into night. And by the time we reached orbit, it was pitch black outside, and shortly thereafter came our first orbital sunrise during the rendezvous to ISS. And I will never forget that sight, the thin blue line of the atmosphere, the curve of the horizon. That's when it became real, really at a gut level. I'm actually in space. We are on orbit. This is not a sim. Because your mind tends to go the reassuring route of pretending it's just a game. But no, that this is reality. We are in space, in orbit. And that view, that sunrise, I'll never forget that. Through the crummy little side window of the Soyuz, still just amazing. It's like burned in my memory. I, of course, spent a lot of time at the cupola, looking at the Earth. And what has always struck me every time I went there is how beautiful the Earth is, how fragile it looks, how alive it obviously is with the clouds, the water. It's like it's breathing. The auroras, the presence of humans at night, it's obvious with the lights. But is the death around the Earth that's startling. How this beautiful, shining oasis of life is there naked in the middle of pitch black death, the vacuum of space. And then there's the dance of the celestial bodies around. The moon is there, but the moon is just a rock. The sun is just a ball of fire. And here's the Earth, this perfect oasis. So even though I knew this abstractly, like everybody does now, we have all seen those images, to see it with your own eyes, you develop that sense of awe. And also, you cannot go to space and continue, if you were, thinking that resources are infinite. They're obviously not. It's in your face. It's a finite system, a closed loop system. There's no new air, no new water that gets to Earth ever. It's all recycled and has been for billions of years. And it is perfectly balanced and perfectly matched to our needs. We are matched to her. That concrete realization that we belong to Earth and not vice versa, it's kind of a mental shift to see that we just nowhere else we could go. We can talk about colonizing other planets, but you know, kind of smarter and cheaper to just take care of Earth as she is. So that was very endearing, that vision. And I can close my eyes and always go back to the cupola looking at the planet. And that blue line, it's unbelievable. It makes the Earth look alive. She's glowing. Well, the little bubble we live in is tiny. And that was very, in a way, sobering perspective to get. How fragile, unique, and just sacred, really, our spaceship Earth is, and the responsibility we have to be good shepherds of her. It is the home of billions of humans and billions of other species, completely autonomous in the vacuum of space. It's just a miracle. You want to protect her because it is our only spacecraft. The whole of us, we're all astronauts living in the deadly vacuum of space, kept alive by this beautiful, perfect machine.
If you want another look at any of the stories you saw today, you can. You can find them all on YouTube and Facebook, along with lots of other great features on a wide variety of NASA topics. Now, if you're looking for good conversation about human spaceflight, check out Houston, We Have a Podcast, a weekly show talking to folks involved in all areas of space exploration. Today, as more private companies are starting to launch their own astronauts into space, Gary Jordan talks with the folks from the Commercial Low Earth Orbit Development Program here at JSC about NASA's efforts to enable private astronauts to fly to space. Go to nasa.gov/podcasts for this week's episode and all the previous episodes. The full library of all the NASA podcasts are there, also on Apple Podcasts, Google Podcasts, and SoundCloud.